So, hi Dr. Wang. My ID? Okay. So, I did project number 2. So, what that was is that we're trying to find the 1 mole of this one right here. So, in order to find the 1 mole, we have our 3 original equations, which are written out here. The first step in order to get to the 1 equation is we have to start by canceling the 4NO out. So in order to cancel the 4NO out, you need to multiply the second equation right here, times it by 2. So when you times it by 2, you get the 2 times 2 is 4. So both of these, they're just going to cancel. So they're no longer in the equation. But you know, when you multiply times this, you have to multiply everything. So everything gets multiplied times 2, including the change in h. So the change in h now will be negative 222k. And so now you want to rewrite the equation to be 1 coherent equation. So you take this one, it comes down, these two, because they are like values, you would add them up to get 702. And then you have your 4NO, and you have your 6H2O. And what you would do here is, because these two, they need to be like added together. So you take the negative, and then you'd get your new KJ over there. So that's the new rewritten equation. We're gonna call this equation number 4. That's now equation number 4. So now what we're trying to do now is we're trying to cancel out this 4NO2 because it does not need to be there. It does not need to be there. So now what you would do is like same thing that we did up here when we multiplied the second equation by 2. We would multiply, we're trying to find the common factor between the two of them in order for them to cancel out. So you multiply this 4 equation by 3, so you get 4 times 3 equals 12. And then you multiply the third equation by 4, so that way you get 12 here as well. So you would balance and cancel. So now you're left with a 12NH3 plus 21O2, and then so forth, multiplying these by their respective values. So now you're able to cancel out your 12NO2. So 12NO2 here, they cancel out. And you can even do that with the H2Os because they technically can be subtracted by each other just to get a smaller value. So what we did here was that we took this 4H2O, we subtracted it to get 14H2O over here. So, and as mentioned before, we did multiply, so these are our new KJs. So now we have to put everything back into a singular equation, so we have to rewrite it. So this is this equation right over here, which is already pre-written. The values have been added. So now you have this value right here, which is what we were looking for to begin with. So now we don't have to do anything with the equations. All we have to do is take this value over here in order to find the mole and divide it by 8 because that's that coefficient out there because we want to try to get it on its own. So 1 mole of this will equal negative 494.4 kJ per mole. Thank you.